Who likes bouncy balls? You probably played with a bouncy ball and you maybe even have one in your house somewhere. But did you know that there's more to making it bounce than just molding rubber into a ball? Keep watching to find out more. Here I have two rubber balls. Do they look any different? They're about the same weight, size, color, and shape. I'm going to drop them from the same height. What do you think is going to happen and why? Okay, on the count of 3. 1, 2, 3. Well, that was odd. Can we see that again? Well, it sure looks like they're behaving differently. For our explanation, we will call the one that bounced the happy ball and the other one the unhappy ball. So if I drop them from the same height, why might they be behaving differently? Let's start by figuring out why the happy ball bounced. Gravity pulled it down to the ground. It hit the table, but why did it bounce back up? Balls bounce because they are elastic. They can be deformed, then return to their original shape. So even though the two balls look the same, the happy ball quickly returns to its original shape once it's deformed, and the unhappy ball does not. So what is it that causes them to behave differently? These two are made of the same kind of rubber. However, one is vulcanized and one is not. Vulcanized means that the rubber has been specially treated by adding sulfur and a lot of heat, and this changes the molecular structure of the rubber. Molecules are the tiny pieces that make up everything around you and determine the different properties of materials. Untreated rubber is made of long, flexible molecules like the one shown here called chain polymers. Now, the terminology doesn't really matter. You can think of these as lots of long strings that aren't really connected very strongly. When the rubber is vulcanized, however, connections are formed in between the long strands to make them stronger, and that's what makes it want to go back to its original shape after impacting the ground. This allows it to bounce back up with lots of energy. The unhappy ball lacks these connections, so the rubber doesn't return to its original shape after deformation with the same energy, so it does not bounce back. Once scientists figured out how to vulcanize rubber, huge improvements were made to rubber products. So now we know why these two different balls bounce differently. But there are other ways to change its bounciness. Here I have two happy balls. You can see if I drop them, they bounce about the same. Now what do you think is going to happen if we put one of these balls in the freezer? Let's try it. So I just took this ball out of the freezer. Now I'll drop it alongside another happy ball. And now I have the cold happy ball and the unhappy ball. Let's compare them. See, it bounces less, but still more than the unhappy ball. Is this what you expected to happen? Maybe you expected it to be different because you set it up that way, but why does cooling it down make such a big difference? In general, when we freeze something, it starts to look something like this. The particles are really organized and the interaction between them is really strong. A room temperature happy ball might look something like this. The structure of this material allows it to bounce much better because it is less rigid. So what's the point? You wouldn't make a table out of rubber or a shoe out of concrete. There is a whole field of science dedicated to finding what materials are best for certain objects. This is called material science. It goes way beyond what kind of rubber is the bounciest. Some material scientists even have to figure out what kinds of materials are best for spaceships. Spaceships are made of a special type of aluminum called an alloy. This means the aluminum is mixed with small amounts of other metals to give it desirable properties. What might some of these properties be for a spaceship? Spaceships need to be light, durable, and resistant to heat. These attributes are tough to find in a metal, so material scientists sure have their work cut out for them. You might be thinking, what does this have to do with optics? But all branches of science are connected, and they are all very cool in different ways. Without collaboration between these different branches, we wouldn't be able to make much of the technology we have today.